Welcome back, learners. This is your teacher, Professor X, and we are solving past paper today. So, this paper was the hardest paper that has ever been given in pure mathematics 3. This paper has been rated the hardest. So, let us try to solve this question, and I will make this paper the easiest one for you. If you sit with a notebook and pen and start solving with me. Sketch the graph y equals to mod x minus 2a where a is a positive constant. Alright, so we have to sketch a graph. So we know y is here, so we will form a y-axis, and x is there, so we'll form a x-axis. Now the point to be noted is that a is constant, a is not a variable. So it has a constant value. We don't know that value, but a is constant. So how can I draw this graph? By making 2 points. First of all, tell me where will the value of y be 0 when x is twice a? 2a minus 2a is 0. And y is 0 on x-axis. So over here on 2a, y equals to 0. This is the first coordinate. The second one would be where x equals to 0. Put x equals to 0. So it would be 0 minus 2a. That would give us, very good, y equals to mod negative 2a. Y equals to 2a. So over here x will be 0 and y is 2a. Alright. Now draw a line like this. And about the symmetry, draw another line like this. This is your graph, learners. Got this one? Easy or hard? We need 2 points to draw any graph, right? So what I did was, I write the value x and y. I put x0, so y would be 2a, right? And if I put x 2a, y equals to 0. I got those points and then I reflected it. Because whenever you put a modulus, the value of one function can never be negative. It can never be negative. Alright? Let us move on to the next question now. Now let's try to solve this inequality. 2x minus 3a is less than x minus 2a. Before thinking anything, let's follow the steps. So we will remove this modulus sign and equate it to 2x minus 3a less than x minus 2a, and then 2x minus 3a is less than negative of x minus 2a. This is what we do when we remove the modulus sign. Yes or no? Put the positive value and the negative value. Now, I will subtract x from both sides, so it will become 2x minus x is x minus 3a less than negative 2a. Then add 3a to both sides. It will become x is less than a. Okay. Now, let's try this one. Multiply by negative. It will become 2x minus 3 less than negative x plus 2a. Okay. Add x to both sides. These will be cancelled. 3x minus 3a is less than 2a. Add 3a to both sides. It will become 3x less than 5a. Divide by 3, divide by 3. X is less than 5 upon 5a by 3. We got two values. Let's check. Now, check. This is the most important step which you always miss. So take a lesser value than a and put it inside there. Okay, this is the simplest method which I am teaching you. So we'll put a by 2, which is less than a. Okay, so it would be 2 times a by 2. I'm replacing x with a by 2. Okay, minus 3a is less than a by 2 minus 2a. Now let's check if it is true or not. This would be negative 2a is less than, this would be 2 times 2 is 4, negative 4 and negative 3 by 2a. This would be negative 2a is less than 3 by 2a. Is it true or not? Yes, sir, it is true. All right. So this satisfies. Now let's check for this one. Take a smaller value. Can we let's take a because a is also smaller than this. Yes or no? Let's put a over here. So this would be 2 times a minus 3a less than a minus 2a. That would give us learners negative a is less than a. Is this also true? Yes, sir, this is also true. So what will be our answer? See, both satisfies. So the value of x, let us represent this on a number line. So this is a and this is 5a by 3. It is true for all the values less than a. It is true for all the values less than 5a by 3. So can I write it like this? X is less than 5a by 3. This is the final answer. Because in this, see, this is also included. Is this included in this one? Is x less than a included in x less than 5a by 3? Yes or no? It is going till negative infinity. So this range will be included in this. Are you thinking with me, A level students, or not? So this will be our final answer. Very good, learners. Let us move on to the next question now. All right. So the next question states express. We have to express this in partial fraction. Before expressing, tell me one thing. Tell me one thing. The powers are same, sir. See, sir, the powers are same. So before expressing, we have to divide. Yes or no? Before expressing in partial fraction, the power of the denominator should always be greater than the power of numerator. It cannot be same as well. Okay, so we will divide. Here comes the denominator. Here comes the numerator. All right, let's divide. Let's try to make this same. So we will multiply by 3. So it would be multiply completely by 3. It would be 6x square minus 15x negative 36. Now what do? We subtract. Minus plus plus. In subtraction, we always change the sign. This was positive, so it became negative. It was negative, it became positive. It was negative, it again became positive. So this would become 6x plus 20. Agreed? Agreed or not? So the new function would be fx equals to, this was the quotient, so I will write 3 plus 6x plus 20 upon 2x square minus 5x minus 12. It's better that we factorize this one now. You can do that by middle term splitting. Okay, so if I split the middle term, it will come as, this would be 2x square minus 8x plus 3x and then minus 12, which would give me 3 plus 6x plus 20 and 2x plus 3 and x minus 4. Sir, I don't know how to do middle term splitting. No worries, beta. Just put this in your calculator and you will get two answers. Your first answer would be negative 3 by 2 and your second answer would be 4. So we have x equals to negative 3 by 2 and we have x equals to 4. Take this to other side, it will become x minus 4. First multiply this. Never do this. So this is the common mistake which you can do. You can do like this as well. Don't do this. Repeat after me. I will not do this. I will not do this. I will not do this. So what you will do is, first you will multiply by 2. It will become 2x equals to minus 3. Then take this negative 3 to one end. It will become 2x plus 3. Now multiply these both and your term is factorized. Got this one, learners? Very good. Now partial fraction is very simple. All of us know how to do partial fraction. If you don't know, so this would be 3 plus, I'm taking this into partial fraction. So I'm doing this over here. It would be 6x plus 20 upon 2x plus 3. We have many methods. We have heap side cover up method as well. But I am teaching you a simpler method today. A upon 2x plus 3 plus b upon x minus 4. Okay, can I write it like this? We know that this will be multiplied by this one and this will be multiplied by this one. So it would become 6x plus 20 upon 2x plus 3 and x minus 4 equals to a times x minus 4. This is the cross multiplication which we do, plus b times 2x plus 3. Just taking the LCM over here and multiply these two by each other. So it would be 2x plus 3 times x minus 4. These will be cancelled. We will have 6x plus 20 equals to a x minus 4 plus b 2x plus 3. Yes or no? Now, if I put x equals to 4, this term will become 0. So put x equals to 4. So it would be 6 times 4 is 24 plus 20 is 44 equals to, put 4 over here, 11b. So b would be 4. You got the value of b? Put any value of x, any value if you want. So we can make this 0 as well. How can we make this 0? We can put x as negative 3 by 2. Okay? So by putting negative 3 by 2, we will get, and plus 20 equals to, see, negative 3 by 2. So this term is 0 now. This term is 0. We will have a times negative 3 by 2 minus 4. Yes or no? Tell me yes or no. Yes or no. So this would be 11 equals to, and now solve this one, it would be negative 11 by 2 a. So the value of a from here would be negative 2. We got the value of a and we have the value of b as well. Can you see this? We have the values. So how can I write it in partial fraction? I can write it as a upon 2x plus 3. So it would be negative 2 upon 2x plus 3 plus b upon x minus 4. So it would be 4 upon x minus 4. Show me a thumbs up till here. Show me a thumbs up and I'm erasing this part. Okay. You want to take a screenshot? You can take a screenshot. You want to check something? Go forward and check. Take a screenshot. Take a deep breath. Take a sip of water. All right. Pause. Rewind the video. But stopping is not an option. All right. Let's go. Let us move on to the next question now. The variables x and y satisfy the equation where a and b are constant. Show that the graph of y against x is a straight line. Now, this might seem to you a new question, but it is simple. Really simple question. We have studied this. Repeat after me. We have studied this. Yes, we have. So, how can I prove that the graph of y against x is a straight line? Let me show you. A 2y minus 1 equals to b x minus y. Have you learned this in logarithms chapter or not, that we can arrange this in the form of y equals to mx plus c? Have you learned this or not? If anyhow I can arrange this equation in the form of y equals to mx plus c, can I show that the graph is a straight line? Because straight line graph can be arranged in this form, yes or no? Y equals to mx plus c, where c is constant, we have a value for c. Where m is constant, we have a value for m. And these two are variables, okay, where y depends upon x. Say yes or no, learners. Why are you sitting like this? Okay, very good. Now what can we do is, we can take ln both sides. The power will come out. The power will come out. What was the idea behind taking ln? The idea was to take the power out. And whenever you want the power out, take ln on both sides. Repeat after me. I will take ln on both sides. Yes, you will. 2y minus 1 ln a equals to x minus y ln b. Am I right or am I right? Yes, very good. Am I right? So multiply this bracket, multiply this. It would be 2y ln a minus ln a equals to x ln b minus y ln b. Yes or no? Okay. Now what can we do now? We can take y terms to one side and the rest to another side, because we need y as the subject. See over here. Think with me like a mathematician. We need y as the subject. So we want to take y terms to one side and the rest term to the other side. So if I take y terms to one side, this would be 2y ln a plus y ln b equals to x ln b plus ln a. See, these are constants because a and b are constants. Okay, let's go. Because it is written where a and b are constants. Now, what I can do is I can take y common from here. This would be 2 ln a plus ln b equals to x ln b plus ln a. Okay, let's put it into division. So y equals to x ln b upon 2 ln A plus ln B plus ln A upon C. It will be divided by both of them, yes or no? If it's going to other side. Yes or no? We never take things to other side. We divide both side by divide each term by this one. Okay, each and every term. So this would be 2 ln A ln B. See now compare. We have y, we have x. This one would be m, the slope, and this one is the y-intercept that is also constant. See this value is constant. This value is also constant. What do you mean by constant? It has a specific value, and these two values will change. So so it is a straight line. Write this, okay? Okay, it is a straight line with gradient and intercept. With gradient and intercept, learners. You got this one? Very good. Now we have been given that. Given that. Now see, look very carefully in this question. This is another simpler question. We have been given that a equals to bq. State the equation of straight line in the form of y equals to px plus q, where p and q are rational numbers in the simplest form. Now we want to remove this logarithm. Okay, so we had the equation y equals to x ln b upon 2 ln a, okay, plus ln b plus ln a upon 2 ln a plus ln b. Okay, before doing this question, you should know if I have ln b plus ln b, whenever we add, we multiply them. Okay, so this one would be ln b times b. That would be ln b square. Now, let us replace a by bq. So it would be y equals to ln b upon twice ln bq plus ln b plus ln b cube upon twice ln b cube and plus ln b. Yes or no? Now listen and now think with me also. If I write ln b square, can I write it like this? 2 ln b. Can I write it like this? Power comes to the coefficient. Yes or no? And multiplies. But I can also write this like this by putting this 2 in power. Can we do that, the opposite one? Yes. This 2 will go in power. So this will become x ln b think with me very carefully. Think with me, learners. This would become ln b to the power 6. 2 times 3 is 6. Yes or no? Plus ln b plus ln b cube upon twice 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 ln b cube. The same we will repeat over here. This 2 will go in power and plus ln b. All right. So this would be y equals to x ln b. Now listen, these are in addition. So these two will be multiplied. I've told you. Whenever we are adding ln a plus ln b equals to ln a times b. Okay, ln a times b. So I will multiply these two and it will become ln b to the power 7 plus ln b cube upon the same case over here ln b to the power 7. See, ln b to the power 6 times b, it will be ln b to the power 7. Can I take this out now? Yes, sir. So y equals to x upon x ln b, 7 ln b plus this is out going out, bro. 3 ln b upon 7 ln b. ln b ln b cancelled, ln b ln b cancelled. So we will have our final answer y equals to x by 7 plus 3 by 7. Got this one or not, learners? Show me a triple thumbs up now. Oh, sir, we only have two thumbs. Okay. Okay, and then show me a double thumbs up. All right. Let us move on to the next question. The equation of a curve is y to the power y e to the power 2x plus y square ex equals to 6. Find the gradient of the curve at point where y equals to 1. All right. Simple question. Let's do it together. Product rule, you should know product rule. We are going to apply product rule in this. Okay. So what we will do over here is, let's apply product rule over here. First, differentiate the first term dy over dx. Differentiation of y is dy over dx. Keep the second one same. So it would be e to the power 2x. Now keep the first term same and differentiate the second term. The second term differentiation is e to the power 2x. Differentiation is 2 e to the power 2x. Yes, sir. Plus, the same case we will do here. First, we will differentiate the first term. Differentiation of y square is 2y dy over dx. Okay? And e to the power x will remain same. In second time, we will just keep the first term same, that was y square c, and differentiate the second term. E to the power x differentiation is e to the power x only. And the differentiation of 6 would be 0. So we'll put 0 over here. This is the common mistake which you may do, and many students does, that they put 6 over here to the other end, and then their answer don't come. And then they reply, that's why my answer is not coming. Now the next step would be substitute y equals to 1 in here, over here, over here, and over here. Alright? So if I substitute y equals to 1, now the next step would be to substitute y equals to 1 into the equation. So if I substitute y equals to 1, it would be e to the power 2x plus e to the power x equals to 6. Agreed or not? Yes or no? Very good. So what we will do over here is, one mistake which students usually do is take ln on both sides. It is not at all required. See, in dy over dx, we just need the value of e to the power x or e to the power 2x. We can write e to the power 2x as e to the power x square. So we just need the value of e to the power x. So we will take e to the power x as y. So this one would be y square. See, e to the power x is e to the power 2x is e to the power x squared. So this one will be y square plus y. Take this to the other side, minus 6 equals to 0. We will get our two values, and that would be e to the power x equals to minus 3 and e to the power x equals to 2. Yes or no? We will ignore this value, e to the power x equals to minus 3. We will take this one. So we will substitute this e to the power x equals to 2 and y equals to 1 into our equation, this one, this equation. And we will get as dy over dx times e to the power 2x. If e to the power x is 2, what would be e to the power 2x? Square of 2, that is 4. Yes or no? So dy over dx times 4 plus 1 into 2 times 4, that would be 8, plus 2 times 1 is 2, times 2 is 4. So 4 dy over dx plus 1 times 2 is 2 equals to 0, learners. Very good. Now by solving this, we will have 4 dy by dx. 4 dy by dx will give us 8 dy by dx. 8 plus 2 is 10 equals to 0. So our dy over dx equals to negative 10 upon 8, and dy over dx equals to negative 5 by 4. This is your answer, learners. Very good. You got this one also correct. Let's move on to the next one now. So the next question says, it is given equation is e to the power 2x equals to 5 plus cos 3x has only one root. Show by calculation that this root lies in the interval 0.7, 0.8. This root lies in the interval. All right. So what we can do is take all of this to the left hand side. This would be e to the power 2x minus 5 minus cos 3x equals to 0. You can substitute the value 0.7. If we put x equals to 0.7 in our calculator and put it over here and over here, you will get the answer as, let me put it, minus 0.440. All right. Now put x equals to 0.8 and you will get your answer as 0.690. Can you see the change of sign? So change of sign indicates the presence of root. The presence of root. Show that if a sequence of values in the interval is given by the iterative formula, this one. Okay. So we will start with this formula, x equals to half ln 5 plus 3 cos 3x. Sorry, 5 plus cos 3x. All right. Now we have to make this formula look like this one. Can we do that? Yes, we can. We will multiply this by 2. It would be 2x equals to ln 5 plus cos 3x. Now take everything to the power of e. e. All of us know that e to the power ln x is x. E to the power ln x is x. So this would be e to the power 2x equals to e to the power ln x is x. So it would be 5 plus cos 3x. This is your answer. See, we can frame this equation like this one. So we'll write QED after this. Okay. Hence proved. Okay. Now use this iterative formula to describe the root correct to 3 decimal places. Okay. So we will find out various values. This is xn, this is xn plus 1. So this would be our x2 and this would be our x1. We will see where these values come closer or come same up to 3 decimal places. So what we will do is we can start with any value. Okay, you can start with any value and start putting the values. So we'll put x1 0.70000. In the formula, in this formula, I'm writing the formula over here. X n plus 1 equals to half ln 5 plus cos 3x to the power n. Put these values and check the answer. X2 0.75150, x3 0. Put the values instead of x. It would be 0.73719. Then we'll put x4 0.74105, x5 0.74000, x6 0.74028. Okay, whatever answers we are getting, we have to just place it inside here. Okay, over here instead of x, then calculate the answer. The next one, if I put this over here, then what will we get? X7 we will have 0.74021. See, up to 3 decimal places these three are same. Up to 3 decimal places our answer would be 0.740 to 3 decimal places, right? 3 decimal places, these are same or not? These are not same, but these three are same. So the solution would be x equals to 0.740. Now the question is from which value to start, sir? We all know that the root was between 0.7 and 0.8. So you can start from 0.7 or you can start midway between them, that is 0.75. You can start from any value between them and you will reach the answer. Okay. Now let us move on to the next question. The next question says the diagram shows the curve y equals to x e to the power minus ax, where a is positive constant and its maximum point is m. Find the exact coordinates of m. Exact coordinates of m we have to find, and we know it is a maximum point. So what do we mean by maximum point? Dy over dx equals to 0. The gradient is 0 over here. See, yes or no? The tangent at this point, the gradient would be 0. So what we will do over here is, first of all, to find the exact coordinates of it, we can differentiate it. Okay, so what we will do here, we will apply product rule. All right, so what is product rule? First differentiate this one. So dy over dx equals to x differentiation would be 1 times e to the power minus ax plus, keep the x same, x times differentiate this one. This one would be minus a times e to the power minus ax. Yes or no? Yes, sir. So dy over dx equals to e to the power minus ax plus minus ax e to the power ax. Now this one would be dy over dx equals to e to the power ax minus ax e to the power ax. Take this common. Okay. Can I take it common or not? Tell me. This is negative. Okay. This is negative. This is also negative. So I will take this common. Dy over dx equals to e to the power minus ax 1 minus ax. Put it equals to 0. So 0 equals to e to the power minus ax 1 minus ax. First equate this equals to 0. Okay, and this also equals to 0. E to the power minus ax equals to 0. It will have no solution. How can a power to e exponential be 0? No, it has no solution. Now let's talk about this one. 1 minus ax equals to 0. Okay, so ax equals to 1 and x equals to 1 by a. Now, now we have x equals to 1 by a, so put 1 by a over here. So y equals to 1 by a e to the power minus a times 1 by a. Our equation was this only, now y equals to x e to the power minus ax. So instead of x, I placed 1 upon a. So these two will be cancelled. So we will have y equals to 1 upon ae. Understood? Why ae? You can write it like this as well, e to the power minus 1 upon a. That is also fine. But if you reciprocal it, it will become like this. So what will be our coordinates? The coordinates would be x coordinate first 1 upon a and 1 upon ae. This is your answer. Let's move on to the next one. Find the exact value. See, over here we have to use by parts. We have to use by parts over here. Yes. So what we will do is we will make 4 columns. This one, this one, this one, and this one. This is the easiest way of doing by parts, 4 columns. We'll put u, v, all right, du, dv. Done? Very good. So what is the value of u? How can we decide the value of u using ILATE? Inverse first, logarithms, algebra, trigonometry, exponential. This is the preference of choosing u. So over here I can see algebra and exponential is there. So we'll use algebra as u. So u equals to x. All right. And the remaining part, this remaining part equals to dv. Yes or no? So it would be e to the power minus ax dx. Okay. Now what we will do is we will differentiate this one and integrate this one. Opposite we are going. So if I differentiate this one, du equals to dx. Yes or no? How? Du over dx equals to 1. If I differentiate this and dx will go there, so du equals to dx we got. And integrate this one, we will have v equals to e to the power minus ax divided by minus a. If you agree with me, show me a thumbs up. Yes or no? Yes, sir. Very good. You got this one correct? Now let's put the formula. We have the formula u dv equals to uv minus v du. See, this is the opposite of product rule. All right, it is the opposite of product rule. So we have determined u, we know dv as well. To integrate it, we should know uv, we know u and we know v as well. This is v. We know v and we know du as well. Du is over here. So put the values. Listen very carefully. What is u? What is u but x? Very good. Times by v. What is v? This one. E to the power minus ax upon negative a minus integration of v. What is v? Again this one. E to the power minus ax upon minus a times du. What is du? Du is dx. Yes or no? Du is dx. So I will integrate it. Now, now let us proceed further now. This would give us x e to the power minus ax upon negative a plus, see this minus will come out, it will become plus e to the power minus ax upon a dx. No need to do anything over here, just integrate this one with respect to x. This would give us x e to the power minus ax upon negative a, and integrating this, so we will divide it by minus a again, minus e to the power ax upon a square. We are dividing this by minus a again, no? E to the power minus ax integration is with respect to x, e to the power minus ax upon a, negative a. So negative a times a will give us negative a square. Yes or no? And negative sign will come over here. So it will become negative. Okay, we got this one. Now we will apply the limits. What is the limit, my friends? Limits are 0 to 2 by a. So we will apply the limit 0 to 2 by a, upper limit minus the lower limit. Let's apply limit 1 by 1. Instead of x, we will place the limits over here. Okay, over here we will place the limit, upper limit minus the lower limit. First I am placing 2 by a. Now we will substitute the value. Instead of x, it will give us 2a upon negative a times e to the power minus a and 2 by a minus, again instead of x, so e to the power minus a 2 by a upon a square minus the lower limit. If I put 0, this whole term will become 0. Yes or no? And this will be 0 and e to the power 0 will be 1. So minus 1 upon a square, I guess. Yes or no? See, this will become 0 minus 1 upon a square. So this is written over here. Simplified further, over here we will get this a will be cancelled. This will become down and become negative a square. And these a will be cancelled, which would give us negative 3a square e to the power minus 2 plus 1 upon a square. Can I take 1 upon a square common from here? Yes, sir, you can. And we will get 1 minus 3 e to the power minus 2. Yes, it is important to give the answer in factorized form. It is really important. All right, let's look at the next question now. Show that. Now here is where you can apply various methods, but I will use the simpler one. It's the simplest method to solve this question. Okay, don't think too much in these type of questions. Why am I saying so? I will tell you why. See, our first priority is to just reduce these four powers and make it a square. To do that, I will move, because I have to make cos over here, so I will change it into cos form. Cos to the power 4 theta minus, now look over here. Can I write it like this? Sine square theta square. So it would be cos 4 theta minus cos square theta plus sine square theta equals to 1. So sine square theta equals to 1 minus cos square theta. Agreed? Open the square. Cos 4 theta. Why am I doing so? First of all, I have converted everything into cos. Now I want to just take away this power. Yes or no? I just want to cancel this term, this term. So what I did was, if I know that if I square this, it will become cos to the power 4, and it will cancel it because minus is outside. So see what happens. If I expand this, it will become 1 plus cos square theta minus 2 cos square theta square minus 2 cos square theta. Yes or no? So this will become cos to the power 4 theta minus 1 plus cos to the power 4 theta minus 2 cos square theta, which will become cos to the power 4 theta, minus is outside, change the signs, minus 1 minus cos 4 theta plus 2 cos square theta. These two will be cancelled, which will give us 2 cos square theta minus 1, which is cos 2 theta. And yes, this is what we have to prove. This is the identity, right? Cos 2 theta equals to 2 cos square theta minus 1. You can look for it in MF19 as well, and this is your answer, learners. Let us move on to the next question. Hence find the exact value. Hence find the exact value of cos to the power 4 minus sine 4 plus 4 sine square cos square d theta. Yes. No, here we have to integrate. By doing this, half of our work is done. It has become easier. How? Let me show you. So we have to integrate for negative pi by 8 to pi by 8 this function. Can I write instead of this cos 2 theta? Can I write it? Yes, we can write it. Cos 2 theta. Very good. Now listen. This would be cos 2 theta plus 4 sine square theta cos square theta d theta. This problem is solved. We can integrate it easily. What is the integration of cos 2 theta? Yes, shout with me. 1 by 2 sine 2 theta. 1 by 2 sine 2 theta. Yes or no? Yes. Very good. We will integrate this one. So this one would be 1 by 2 sine 2 theta. The integration of cos 2 theta. We have integrated cos theta, that is sine theta, but it was 2. 2 was over here, so we divided by 2. So sine 2 theta by 2. Problem lies over here. Can I write it like this? 2 times 2 times sine theta times sine theta times cos theta times cos theta. Think with me, can I write it like this or not? Can I? Yes. Now see, 2 sine theta cos theta is sine 2 theta. Again, 2 sine theta cos theta is sine 2 theta. It will become sine square 2 theta. Will it become or not? Will it become or not? Will it become or not, learners? Now, I don't know the integration of this part. So what I will do is, I know this identity, sine square theta equals to, I hope you know this, half minus half cos 2 theta. I hope you know this. So we have 2 over here. So here it will become 4. So I will change it. I will change it and I will make it like this. To remove the square because I don't know the integration of square, right? So it would be 1 by 2 minus half. Now wait, let us integrate it directly and put it inside the bracket. So it would be, what would be the integration of 1 by 2? Tell me. It would be 1 by 2 theta because we are integrating with respect to theta. What is the differentiation integration of 1? It is x, right? If we are integrating with respect to x. Integration of 1, if we are integrating with respect to theta, would be theta. Okay. So 1 by 2 theta. Integration of 1 by 2. What is the integration of negative half cos 4 theta? So we integrate this part. Cos 4 theta would be sin 4 theta by 4. Agreed or not? Agreed or not? Now this 4 and this 2 will be multiplied and we will get negative 1 by 8 sin 4 theta. The limits would be negative pi by 8 to pi by 8. Now we'll put the values for theta. Now let's plug in the values. Upper limit instead of theta, that would give us half sine 2 times pi by 8. See, I'm putting in the upper limit first. 1 by 2 times pi by 8 minus 1 by 8 sine 4 times pi by 8 minus the lower limit. That would be this one, which would give us 1 by 2 sine 2 times minus pi by 8 plus 1 by 2 times minus pi by 8 minus 1 by 8 sine 4 times minus pi by 8. Alright, put this in your calculator. Directly you can put this in your calculator if you want, or you can solve it individually, find the values of these functions. Okay, so we will get 1 by 2 times root 2 by 2 plus pi by 16 minus 1 by 8 minus 1 by 2 times minus root 2 by 2 and minus pi by 16 plus 1 by 8. Subtract them. You will get your final answer as root 2 by 2 plus pi by 8 minus 1 by 4, learners. Very good. Let us move on to the next question now. This one. Now, in vector question, you have to visualize with me and then solve the question. The points A, B, and C have position vectors. O is the origin. The line L1 passes through B and C. See, the line L1 passes through B and C. You have to find the vector equation. To find the vector equation, we need to know any point on that line. So we have to know the coordinate of B, we know, or we can know the coordinate of C as well. We know that as well. Done? Yes or no? Now we have to find the direction vector. One is the position vector, which we know. Next is the direction vector. Direction vector for BC would be OC minus OB. Yes or no? That would give us 8, 5 minus 3 minus 5, 2, 0. And our answer would be 3, 3 minus 3. Alright, so the equation of line would be, you can take any point. You can take any point. I'm taking OB, you can take any point. 5, 2, 0, this is OB plus lambda. And what is the direction vector? 3, 3 minus 3. This is your answer. Okay, equation of line. Let us move on to the next question. The line L2, this is the equation of L1, okay? L1. Now, line L2 has an equation R equals to minus 2i plus j plus 4k and mu 3ij minus 2k. Find the coordinates of the intersection. Okay, so let us know about the coordinates. L1 equals to 5 plus 3 lambda, 2 plus 3 lambda, and 0 minus 3 lambda. Agreed? L1 is this. What is L2? L2 is, again, the point of intersection will be equal, right? So it would be minus 2i plus 3 mu. So minus 2 plus 3 mu. And the next one would be 1 plus mu. See, 1 plus mu, mu will be multiplied. And 4 minus 2 mu. Very good, learners. Equate them, equate these, and find the value of lambda and mu. So we will have 5 plus 3 lambda equals to minus 2 plus 3 mu. That would give us 7 equals to 3 mu minus 3 lambda. Yes or no? Let this be equation 1. And equation 2 would be 2 plus 3 lambda equals to 1 plus mu. See, equate them. So 2 minus 1 would be 1 equals to mu minus 3 lambda. This is equation 2. Solve them simultaneously by solving 1 and 2. You can put it in your calculator as well if you want, or you can use elimination method. What will we get? You want me to solve it? Okay, I will solve it. 7 equals to 3 mu minus 3 lambda. 1 equals to mu minus 3 lambda. See, these two terms are same, so we will subtract. And in subtraction, sign changes. This is positive, it will become negative. This is also positive, it will also become negative. And this is negative, it will become positive. These two will cancel out. 7 minus 1 is 6. 3 mu minus mu is 2 mu, which will give us mu equals to 3. And the value of lambda would be, let's check the value of lambda. Put it in any equation. Over here we are putting it, okay? Are you trying to solve it with me or not? Are you trying or not? Tell me that first. Very good. So we have to find the coordinates of point of intersection. So there's no need to find lambda over here now. Is there a need? No. We can find the coordinates of intersection. Put it in any of the values. So we'll put mu over here. See, listen. These two coordinates will be same, right? So if we find lambda and put the values over here, the answer would be same as here. So what is the benefit of finding lambda? We know mu, we'll put the value of mu over here because the coordinates will be same. So we will have the coordinates as 2 minus 2 plus 3 times 3. Yes or no? And 1 plus 3 and 4 minus 2 times 3. So what would be the answer, learners? The answer would be 7, 4, and this would be negative 2. These are the coordinates of intersection. If we have to prove that these two lines intersect, then we have to find the value of lambda in that case, not in this case. In this case, we can find the value of mu and place it because these two will be equal. Are you visualizing it with me or not? Very good. Let us move on to the next question now. Now let's try this question, learners. The point D on L2 is such that AB equals to BD. Okay, AB equals to BD. Find the position vector of D. First, let us try to understand this. This means that the magnitude of AB vector equals to the magnitude of BD vector. So, to find the magnitude, first let us find AB and BD vectors. Are you ready with me, learners? Alright, so how can I find BD vector? AB vector we can find easily, but what about BD, because we don't know the point D? All of us know that to find AB vector we can do like this: OB minus OA. Yes or no? So what was OB, learners? What was OB? The OB was 5, 2, 0 minus what was OA? Minus 2, 1 and 4. So if we subtract them, this would give us 7. 2 minus 1 is 1 and minus 4. Yes or no? This would be the case. Now, how can I find BD? Because we don't know the point D. But the point D is on L2. The point D is on L2. And what was the equation of line L2? You tell me that. What was the equation of line L2? The equation of line L2 was minus 2i plus j plus 4k plus mu 3i plus j minus 2k. Now, all the points on L2, we can get them by changing this value of mu. Yes or no? We can get all the points. So it would be like this: minus 2 plus 3 mu. This would be the x coordinate. Then 1 plus 1 mu. This would be the y. And 4 minus 2 mu. Okay, this would be z coordinate. Now, this is what we mean by the equation of line, right? This is the equation of line. By changing this value of mu, we can get all points. So for point D, the position vector would be minus 2. So OD we can write like this: minus 2 plus 3 mu, 1 plus mu, and 4 minus 2 mu. Yes, beta. By changing the value of mu, we don't know the coordinate of D, we don't know OD, but we know that for a specific value of mu, we satisfy this, we will get the position vector of D, we will get OD. So for now, OD is like this. Now, to calculate BD, what we can do is BD vector equals to OD vector minus OB vector. Yes or no? So from this, we will subtract OB, this one. Look carefully, I am doing it directly. So BD vector would be OD, that is this, minus 5, that would give us minus 7 plus 3 mu. Then this minus 2, that would give us minus 1 plus mu. Yes or no? Then this minus 0 will be remain same. So 4 minus 2 mu. We have our BD vector as well. Agreed? We have BD vector, we have AB vector. We know their magnitudes are same. So we will just equate their magnitudes. How do we calculate the magnitude? Just square them, add them, and then take a square root. So we know that AB's magnitude equals to BD's magnitude. Why are we doing so? See, to calculate the position vector of D, we need the value of mu, which we will get from here. Are you visualizing it with me or not? First tell me that, learners. So what would be the magnitude of AB? That would be 7 square 49, 49 plus 150, and this would be root 66. Agreed? And what would be the magnitude for this one? Square root this square plus this square and plus 4 minus 2 mu square. Can I square both sides and cancel the root? Yes, sir, you can do that. So 66 equals to, you can expand the brackets if you want. Yes, we have to expand the brackets to find the answer. And what would it give us? It would give us 49 minus 42 mu plus 9 mu square plus 1 minus 2 mu plus mu square plus 16 minus 16 mu plus 4 mu square. Now we'll try to solve it. That would give us 14 mu square minus 60 mu plus 66 equals to this one 66. These two will be cancelled. Okay, so we will have 14 mu square minus 60 mu equals to 0. So mu equals to 0. If mu equals to 0, if we put mu equals to 0 over here in OD, or mu equals to 30 by 7, these two values we get. How, sir? Just factorize it, beta. Mu 14 mu minus 16 equals to 0. So first is mu equals to 0. Then by putting this equals to 0, we will get 30 by 7. Okay? Now listen very carefully. If mu equals to 0 over here in OD, this would give us negative 2, 1 and 4. See if we put mu equals to 0. And negative 2, 1 and 4 are the coordinates of OA. So this cannot be the case. So we will use the value this. And we will have OD equals to minus 2. Put this value instead of mu over here. Okay. Plus 90 by 7. Alright. 1 plus 30 by 7. And 4 minus 60 by 7. That would give us 76 by 7 and 37 by 7 and minus, let us see over here, minus 32 by 7. So these are the coordinates of D, and this is the position vector of D as well. Position vector is same as the coordinate, okay, with respect to origin. With respect to origin, everything is the coordinate. Agreed or not, learners? So, shall we move on to the next question? Yes, let's move on to this one. This one is of complex numbers, all right? So, the first question is simple. They are asking the complex number z and this are defined and express this in this form, and a and b are real and x excel. Okay, so we have to multiply two complex number. So, to multiply them, the process is simple. 1 minus I, 3 plus 3 root 3 I. The basic should be clear. So if we do I times I, that is I square, and that is negative 1. You should know that. Okay. So we'll multiply them. First we'll multiply 1 by both of them. That would give us negative 3 plus 3 root 3 iota. Then we will multiply this by this. It would give us plus 3 iota. Now this is the main negative iota times 3 root 3 iota. Tell me, iota times iota would be iota square. Yes or no? So it would be negative 3 iota square. Iota square value is negative 1. Negative 3 root 3 times negative 1. This would give us 3 root 3. Yes or no? So positive 3 root 3. Now solving it, keeping the real terms to one end, it would give us 3 root 3 minus 3 plus the imaginary part root 3 3. I am taking iota common. So it would give us plus 3 and iota. This is your answer. Let us move on to the next question now. Now in this one, we have to express both of the complex number in this form where r is greater than 0 and the value of theta is also given. Give the exact value of r and theta in each case. So we have to give the exact value. For z first, for the first complex number, it was 1 minus I, right? So first we will find r. R is really simple. Square root of their coefficients. Just square them and add them. So it would give us square root 2. Agreed? Now about theta. First of all, plot these points. So these points 1 and negative 1. So 1 and negative 1 are coming here. So we have to find this angle. Yes or no? Think with me. So it is simpler. So we have tan theta equals to 1 upon negative 1. Yes or no? So what is the value of theta over here? We are working clockwise. So it would be negative pi by 4. So theta is negative pi by 4. So what would be our z? Z is square root of 2 e to the power negative iota pi by 4. The problem is you don't know where to put negative sign and where not, right? So do it this simply. Never put negative in your calculator. Then you will get theta equals to pi by 4. Now what you can do is add sugar to coffee. See, in this quadrant 10 is negative. Only cos is positive, right? So we'll put a negative sign over here. Then you can do like this or not. Tell me one more thing. One more thing. The problem is that sometimes the theta is also here. The angle is also here. Now you will say that sir 10 is positive over here. So should we take positive? No. See, we are working in the opposite direction. Why are we working in the opposite direction? Because the range is given to us between negative pi and pi. If we move like this would be greater than pi. Yes or no? This would be greater than 180. Okay. Whenever working clockwise to find the angle, or in simpler way, I must say that whenever the theta is in these two quadrants, take it negative, and whenever it is in over here, okay, take it positive. All right. Done. Got it. Show me a double thumbs up, and we will move on to the next question. All right, let us move on to this next question now. Oh, wait, we have to find for this one as well. So this would be the same case. We'll find the r equals to square root of negative 3 square plus 3 root 3 square, which would give us r equals to 6. All right, r equals to 6. Now, now we will find the value of theta. Let's find the value of theta. The value of theta would be, just a second. The value of theta would be, let us locate the quadrant. So the quadrant is negative 3, 3 root 3. So this is this quadrant, right? See, negative 3, 3 root 3. So this is this quadrant. Theta will be positive. Yes or no? We will find 10 theta equals to this upon this. 3 root 3 upon 3. Don't put negative, okay? Theta would be from here we will get pi by 3. We got this angle. The calculator gives us basic angle. This is the basic angle. But we have to calculate the actual angle. So how can we calculate the actual angle? The actual angle is calculated by subtracting by 180. So just subtract this by 180 and we will get alpha. Alpha equals to pi by 3 and theta would give us pi minus pi by 3. Okay, we call this basic angle alpha as well. So this is alpha and this is theta. Theta would be 180 minus this alpha, right? Because actual angle is always calculated from here. So which will give us pi minus pi by 3 and that would be 2 pi by 3. Now we know the value of theta. We can put alpha over here to avoid confusion as well. Okay. So we have a theta equals to 2 pi by 3. It would be positive because we are working in the anti-clockwise direction. E to the power 2 pi I by 3. This is your answer. Okay, so the value of r was 6 and a complex number could be represented in e to the power 2 pi by 3i. Okay, let us look at this question. Now this is easier. This is the interesting question and easier as well. Let us try to prove, let us try to prove OAB is isosceles where O is the origin. So first we will draw the axis. This space is given to us to just draw the axis, just draw it, then only we can imagine it, right? So we'll plot the points. This is O. A would be somewhat here. And what about B? B is over here. Am I right? B was 3 root 3 minus 3 and 3 root 3 plus 3. Yes or no? And what was A? A was negative 3 and 3 root. Okay. Sir, why B is this? Because B is given beta. See, it is given that the multiple of both, that was this is B now. This is B point. And this one is point A. Let us join them. Let us join them. This would be somewhat like this and like this, and let's join them now. All right. Now listen very carefully. They are saying that OAB is isosceles. We have to prove that, and the points respectively, O is the origin, up. Now, to prove it, a isosceles right angle triangle, what we can do? This is the real axis. This one is the imaginary axis. Now think with me. Think with me. One thing what we can do is we can calculate OA, all right, the distance of OA, and what we can do is we can calculate OB and we can calculate AB, and we can see which two are coming same. I think from here that AB and OB should come same. Yes or no? Origin is OO. We can calculate directly the distances. And then we can use Pythagoras theorem also to prove it that yes, it is an isosceles triangle. Can we do that? This is one case, and let us try with that only. So what we will do over here is first we will calculate AB. Okay. To calculate the distance of AB, what I am doing is I am first calculating the AB vector, which I have already calculated in previous case. I suppose no, we have not calculated. So we will calculate AB vector first. AB vector is this minus this. So it would be 3 root 3 minus 3 and minus 3. This minus this, that would be 3 root 3 plus 3 minus 3 root 3. So we will get our AB vector as, this would be added and cancelled, 3 root 3, and from here we will get 3. So AB vector we got 3 root 3 and 3. We will calculate the modulus to calculate the length of AB. So the modulus of AB would be the square, which would give us, this is 9 times 3, that would be 36, and we will get AB modulus as 6. Got it? Now we will calculate the modulus of OB. Alright, and let's see what is the modulus of OB. Or we can calculate the modulus of OA as well. And let's see which is coming same. Okay, so first let's try with OA, because I see over here the modulus of both of them will come same. See, because this and this modulus is same. See, I'm calculating OA. Are you visualizing it with me or not? The modulus of OA would be again same, 3 root 3 square plus negative 3 square, which will again give us 6. So OA is equals to 6 and AB equals to 6. That proves that it is an isosceles triangle. Yes or no? That proves it is an isosceles triangle. Hence, it is isosceles. Can I write it like this or not? Can I write it like this or not? Think about it. All right. Now the second step is to prove it a right angle triangle. What we can do to prove it a right angle triangle? We can use theta as well. We know that this side equals to this side, right? We know these two sides are equal. Okay. Now, to prove it right angle triangle, we have to prove any one angle equals to 90 degree. Or we can do one more thing. We can do one more thing. Listen to me very carefully. What I can do is, I can use Pythagoras theorem as well. If it satisfies the Pythagoras theorem, that means it is a right angle triangle. So, I will take this side because this would be the longest side, right? Yes or no? This would be the longest side, OB. So, this angle should be 90 degree. These two sides are equal. We got that. This should be 90, then only this would be hypotenuse and the longest side. So is there any case that I can prove it, by any case that we can prove it 90 degree? Think about it. I'm also thinking, you also think. Can I prove it 90 degree somehow? That would be easier for me. I want to prove this angle 90 degree. what I can do over here? What I'm thinking is I need to find this angle first. I can find this angle, and by this angle, by drawing a line perpendicular over here, these two angles will be equal. See alternate angles. Yes or no? Yes or no? And then I can find this angle, this green one. This green angle would be equals to argument of AB. See, this is argument of AB, right? This is argument of AB or not? Because we are calculating it from the perpendicular. See, this is argument of AB, this green one. So what I will do is I will add this green and yellow and I will get the answer if it is 90 degree and it is a right angle triangle. So how can I find this yellow angle first? Yellow. All right, now listen. We know the argument of OA. Do we? Do we know the argument of OA? Because A was G, A was this one. So do we know the argument of this? Yes. The argument of this was 2 pi by 3. And we know this angle. This was A, right? So this angle was pi by 3. See, this is A over here, right? So we know that this angle would be pi by 3. So this yellow will also be pi by 3. All right. Now how can I find this green one? The argument of AB. Let's calculate the argument of AB. Let's call this green X. How can I calculate X? Argument of AB. And our AB vector was this. How can I calculate the argument of this? That would be tan inverse 3 by 3 root 3. Yes or no? That would give us pi by 6. See, for AB, the point is over here. Both are positive. We have to calculate this angle. This angle is pi by 6. Alpha and theta are same over here. So it would be pi by 6. Green is pi by 6. We got the angle. Okay. Numerator is always y. Okay. And denominator is always x. Now, we want to add these two. So angle OAB equals to pi by 3 plus pi by 6. Agreed? Pi by 3 plus pi by 6, that is pi by 2. Yes or no? This is pi by 2, that is 90 degree. Hence proved QED. Hence it is a right angle triangle. Got it or not, learners? There was a way of Pythagoras as well. Okay. But I have done this question by this method. So I knew this by previous question. This would be same. This is the argument of AB. The angle it is making with this horizontal. Yes or no? We calculated this as well. This is pi by 6. Added them. How do I know that we have to calculate this angle? Because see, these two sides are same. So they only this is the hypotenuse. If this is the hypotenuse, the opposite angle would be 90 degree. Then only it is a right angle triangle. Agreed or not, learners? Let us move on to the next question now. Using your answers to part B, prove that tan phi by 12 pi equals to this. Okay. So the answer for part B. See, we are talking about angles over here. And in part B, we got theta equals to 2 pi by 3 and theta equals to minus pi by 4. Alright. So 2 pi by 3 and negative pi by 4. If I subtract them, I will get 5 pi by 12. Basically, I'm adding both of them, right? So it would be 5 pi by 12 equals to 2 pi by 3 plus minus pi by 4. Agreed or not? What was this, beta? This was argument of W plus argument of Z. Yes or no? Yes or no? That is equals to 5 pi by 12. Okay. Now, if we are adding them, if we are adding the argument, this argument equals to argument of wz. What are we doing over here? We are doing theta 1 plus theta 2, which is the same case for this one. Argument of w times z. Why, sir? Why this is the same case? Let me tell you. First of all, tell me 5 pi by 12 equals to theta 1 plus theta 2. Agreed? Now listen. If I multiply these two complex numbers, okay? So I have z equals to root 2. Z was root 2 e to the power minus pi by 4i. Yes or no? Now listen very carefully. Instead of this, I am writing theta 1. Z equals to root 2, or theta 2 I am writing, okay? Theta 2i. Very good. Now our W was 6 e to the power theta 1i. Agreed or not? If I multiply both of them, I will get 6 root 2, okay, and e to the power. See, the bases are same. Whenever the bases are same, we add the power. Theta 2i plus theta 1i. Yes or no? Take I common. So we will have theta 1 plus theta 2. See, the modulus of the argument and the modulus. Modulus is different. Modulus is different, but the argument is same. So we can write argument w plus argument z, that is theta 1 plus theta 2, as argument of wz. Yes or no? Yes or no? Because argument is theta 1 plus theta 2. And this value is the same for argument of wz. See, zw or wz, theta 1 plus theta 2. What is the argument of zw? It is 6 root 2 e to the power theta 1 theta 2 I. This is the argument, right? So if we are adding them, that is the same as argument of wz. See, this is the argument or not? Yes or no? Modulus is not same. Modulus would be different. Okay, got it or not? We have to calculate the value of theta 1 plus theta 2. So we can write it like this as well. All right. Now I am erasing it. If you have doubt in this concept, do let me know in the comment section, and I will tell you that I'll teach you this again. Okay, don't worry. Now moving back to the question, learners. So can I write it like this? 5 pi by 12 equals to argument of wz. Yes, sir. All right. So what is the argument of wz? What is the argument of wz? We know the point. We know the point. Point was ZW was this one. We know this over here, right? So it would be tan inverse first y coordinate, that is 3 root 3 plus 3 upon x, that is 3 root 3 minus 3. Can we go that side? Tan 5 pi by 12 equals to 3 root 3 plus 3 and 3 root 3 minus 3. Take 3 common and cut it. We will get root 3 plus 1 upon root 3 minus 1 as the value of tan 5 by 5 pi by 12. Got it? Got this one or not, learners? QET. Very good. You got this one also correct, learners. Let us move on to the next question now. If you have any doubts, you can mention them in the comment section. I will answer them. Any doubt in the concept? Feel free to comment that as well. I will answer that as well. Okay. Now, let us try the next one, this one. By writing y equals to sec cube theta as this, show dy by d theta equals to this. Okay. So what are we doing over here? We are writing y equals to 1 upon cos cube theta. That is same as y equals to cos theta to the power minus 6. Applying chain rule, dy by d theta, first take it as u. So u to the power minus 3 equals to 3 minus 3 u to the power minus 4. Agreed or not? And then multiply by u dash. Okay, you know chain rule or not? Or do you want me to solve it? So this would be dy by d theta equals to minus 3 u was cos theta, so cos theta to the power minus 4 times u dash. What was our u? Cos theta was our u, and what is the differentiation of cos theta? That is minus sin theta. So we are applying chain rule. Minus minus would be plus, so this would give us dy by d theta equals to 3 minus minus was plus cos theta to the power minus 4, that is 1 upon cos 4 theta times sin theta, and 1 upon cos is sec. So can I write it like this? Dy by d theta equals to 3 sec to the power 4 theta sin theta. Yes, so hence proved. Okay, let us try the next part. Yes, this is an interesting question for 8 marks, differential equation, and let's try to solve this one. The variables x and theta satisfy the differential equation. All right. So what is the first thing that we do when we see a differential equation? We take x to one side and theta on the other side. So let us do that only first. All right. So I'm taking this complete x to this side. So this would be sine theta d theta over dx equals to x plus 3 cos 4 theta upon x square plus 9. Yes or no? Now this cos 4 theta will come this side and this dx will go to the other side. So this would be sine theta upon cos 4 theta d theta integrated equals to x plus 3 upon x square plus 9 dx. This side would be easier for you. So this would be sine theta sec 4 theta d theta. We know this. Yes or no? Tell me. See over here. We know this. This seems familiar. So what I will do is, to make it more familiar, to get a 3 over here, what I will do is I will multiply and divide it by 3. Sine theta sec 4 theta d theta. Right? So this would give us 1 by 3, 3 sine theta sec 4 theta d theta. Okay, I'm first taking care of this side, then I will move on to this on the next page. Okay, agreed or not? So what would be the integration of this one? All of us know that integration is anti-differentiation. Yes or no? So from the first part, we can write it like this part, anti-differentiation. Whose differentiation was this? Of sec cube? Yes or no? Tell me that. Yes or no? So I can write it like this, 1 by 3 into sec cube theta. And this is done for this one. Let us try to integrate this on the next page. Now, this is very important. This side is really important. So see, what do we have? We have x plus 3 upon x square plus 9 dx. The first step you will do is separate them. Okay? By separating them, we will have x upon x square plus 9, okay, dx plus 3 upon x square plus 9 dx. Done? Now what we will do is, see, the differentiation of this function is 2x and we have x on the top. So what I will do is I will multiply divide by 2 again. Yes or no? We know that fx, f dash x, the integration of this is ln fx. Agreed or not, learners? So first I have to make the numerator the differentiation of the denominator. That I have done by multiplying dividing by 2. So this would give us ln x square plus 9 and half over here. So this is sorted now. Let's look for this one now. This is also simple. Yes or no? This is also simple. So what I will do over here is, I know, let's take the 3 out. 1 upon x square plus 9 dx. I know that the integration of 1 upon x square plus a square is 1 upon a, 1 upon a tan inverse x upon a. You can check it from the formula sheet. You can check it from the formula sheet. So this would be plus 3 times 1/3. See, this is 3 square, right? A square, 3 square. 1 by a, 1 by 3. Tan inverse x by 3. Now we will add plus c to this side because we have differentiated this function with respect to x. So we will add c at the place where we are doing dx. Okay, so plus c. This would give us 1 by 2 ln x square plus 9. This 3 will be cancelled, plus tan inverse x by 3 plus c, and equals to is 1 by 3 times 1 upon cos cube theta. Sec cube theta is cos cube theta only. Agreed or not, learners? Now, at the place where x equals to 3, at, let me change the color now, at x equals to 3 and theta equals to pi by 3. We have to calculate the value of c, right? So plug it in. Plug it in. We will have 1 upon 3 cos cube pi by 3 equals to 1 by 2 ln 3 square plus 9 plus tan inverse g by 3 plus c. Just plug it in into a calculator and you will get c equals to 8 by 3 minus half ln 18 minus pi by 4. Okay, just plug the values and make c the subjects and everything to the other side, and you will get this, the value of c. All right, the next step, let us plug in the value of c into our equation over here. I'm changing the color for that. Let us use blue. So we will have 1 upon 3 cos cube theta equals to half ln x square plus 9 plus tan inverse x by 3 plus 8 by 3 minus half ln 18 plus, no, not plus, minus. Avoid silly errors in your exam paper, alright? Minus pi by 4. Got this one, learners? Yes or no? Now, tell me, we have to find the value of theta. Cos theta basically, right? In this question, see? We have to find the value of cos theta when x equals to 0. So put x at x equals to 0. Okay, at x equals to 0, we will have 1 upon 3 cos cube theta equals to half ln. See, 0 is 9 plus this would be 0 plus 8 by 3 minus half ln 18 minus pi by 4. Done? Yes or no? Tell me that. Yes or no? Take this 3 to the other side. So we will have 1 upon cos cube theta, multiply every term by 3. 3 by 2 ln 9 plus 8 minus 3 by 2 ln 18 minus 3 pi by 4. Okay, and then take cube root on both sides. We will have 1 upon cos theta equals to 3 by 2 ln 9 plus 8 minus 3 by 2 ln 18 and minus 3 pi by 4 to the power 1 by 3. That is the cube root, right? I took cube root on both sides. After calculation and taking reciprocal, we will have cos theta equals to 0.601. This is the final answer. This was not a simple paper. This was the hardest paper which was rated I've checked the ratings. This is the hardest rated paper which can be made, which is made till date. So don't get demotivated if you are scoring less marks in this paper. Comment down the doubts which you have and comment down any paper code which you think is harder than this. I will solve it into the next video. Till the time, keep revising, keep learning. See you in the next video, learners.